Okay, hello. In this lecture, I will quickly cover Git, which is a distributed version control system. So I think most of you already know Git. Some people have said they have not, they don't have much idea. I mean, very small percentage have said they have not used it before. Some of you are really experts of Git, and most of you have used it to some extent. So I'm going with the with that kind of background in mind. Uh, for example, Git is a tool which is like uh, uh, it also evolves. Okay, so a lot of changes keep happening, and Git itself is being actively developed when new and more and more features are coming. And also, you don't probably have to learn everything. Yeah, there is no point in learning all possible options, all possible commands, as just like in many things. So the objective of this particular exercise in this course with Git is so that you get the basic idea of version control, and in particular version control with Git, and by which you are able to manage medium to large projects. Being an expert will require you to consistently work with large code bases, which might happen if you are dealing with some open source development. But otherwise, the Git, the amount of Git which you learn here in this course is good enough for you to be a professional programmer. Okay. So your own software code plus whatever code you develop for your assignments, for your while studying at IIT, and even after you start developing your own code in a company or somewhere, the amount of Git which you learn here should be good enough to get started. And of course, when you do more and more, you'll pick up uh, based on what are the types of actions which you want to do with your code base. You might have to learn them, get to know the more advanced options, or if you have a specific thing to be done for that, you might have to look up online and or check other sources, because the objective of what we are going to do right now is only to understand the basics of version control and how Git can be used, especially while collaborating with several other people. Okay, so the basic scenarios we'll try to cover in this course. I have a presentation which I will present. It is basically, like I said, this probably does not cater to everybody. So, for those of you who already know Git, please bear with me. And for those who already know a little bit of it, this probably will be something to refresh. And for those who don't know anything at all, this could be a starting point. But there are a lot of material available online. Okay, so please do that. How do I present now? Window. Where am I? Why is this not coming? Sorry, wait on, hold on. Okay, it has come now. Okay, I hope you can see these slides, version control with Git. Okay. So most of this material I've taken from the this website, which is officially, I think, the documentation for Git, and this may be for a particular version, but unless you have a very old version, that you should not face any issue here. Most of what we say here will work. There are a lot of configuration options by which you can change the default behavior of Git. So here at this point, I'm leaving everything as default. Okay. Do you need version control? Of course. So that's the first question which you should ask. And as professional programmers, you will say that you will definitely need version control at some point. Okay, so basically, a version control system records changes to a file or a set of files over time. By file, you mean typically source code. Okay, we don't look at object code and or binaries. So typically version control is done for source code, but it can also be done for other types of mostly plain ASCII text. Like for example, if you want to share LaTeX documents, there also you can maintain versions, and you can. The benefit of it is that you can recall specific versions later. Okay, for example, this is an example of a graphic designer or a web designer. So when you develop a website, there are so many things which keep changing as the website is getting developed. You will need a CSS, you will need backgrounds, you will need images, you will need forms, you will need HTML pages, and as the website evolves, the graphic designing team might need to go to the previous state. They might feel that the previous version is better. Entire project you want to go back to the previous state. If you show it to the client and the client says no, this is not what I want, go back to the previous one. Then you can go back to the previous one and start from there. You can also track who changed something that caused an error when there are multiple people involved. And of course, the main thing is you can also easily recover files that are deleted or changed. Okay, so those are the main motivations of why we need to use version control. So typically, if you don't use version control, lazy users will typically do this. There's some project which you want to back up. There's a directory where all your source code is there, and so you just do make a copy, project 1_back, or if you want to make a copy on a particular day, August 21, 2019, something like this, you can make. Okay, but of course this is error prone. First of all, you'll have to maintain all these versions, and you might do the you might overwrite the wrong directory. So generally, in version control, we have let's say a particular file here which you want to do the version control, and there's a version control database which maintains different various versions of the file: version 1, version 2, version 3. Now, there are centralized version control systems. For example, there are there is a version control server, and there are various users. And let's say one user sitting in computer A and another user sitting in computer B. So there is a master copy in the VCS server, and then you use what is known as traditionally called as a checkout. So if you want to edit a particular file, you check that file out. So when you have checked out the file, nobody else will be allowed to check out that file. So if you want to edit a file, you check it out, you edit, make your changes, and check it in. Okay, but so the VCS ensures that if you have checked out a file, if somebody has checked out a file, nobody else will be able to edit that file. So that is the way it manages various versions, and it also keeps track of the differences among the various files and various versions. Right? And so earlier version control systems used to be like this. Okay, and a classical version control system is SVN. It's called Subversion. It used to be common in Unix. The problem is with this is that there is a single point of failure. Okay, if the server is down for some reason, then you will not be able to. Nobody will be able to access anything because everything is there on the server. You have to check out things on the server to do any amount of coding. There is no local copy. But in distributed version control, everybody has a copy of the entire source code. The entire there is a server. The server has some version. I mean, server has a database which maintains versions. Most of the time, the server will only contain metadata. The actual files remain with the users. So every user will have a clone of the full data. Okay. So all the clients fully mirror the repository, including its history. So everybody knows what everybody has done, and whatever is there in the server is there with everybody. Okay, so this is not just a source code. The history of how the source code changes is also there. Git is a distributed version control system. So in traditional version control systems, SVN, like SVN, which I said, the versions are maintained by the deltas. I mean, how much a file has changed. For example, if there is, let's say, version 1, which is file A, B, and C, you make some changes to file 1 and you call it file A, and file C and you call it version 2. So in version 2, we'll store only the difference between the what is version 1 and version C, and I mean, what is version 1 of file A and version 1 of file C. So that delta is what is stored. So these are the so like this for various versions. Each time you make a change, you make a different version, and you store the various versions, and the VCS keeps track of the deltas. Whereas in Git, the other, so it's not really the deltas. The Git actually takes a snapshot of the entire file system, which contains the source code, where the source code is present. For example, and it does it in a very efficient way. So in version 1, there are 3 files, A, B, C, and you suppose you change file A and file C, and that's called A1 and C1, and you call it version 2, and B is not changed. So when you take a snapshot, so when you do a commit in Git, when you do a snapshot in Git, so it takes a snapshot of the current state of the file system, and whatever is not changed is it's just a pointer to the original file. So it is also fast and it is also efficient in storage. Similarly, so like this, so there is no explicit mention of deltas. The deltas are the versions, the snapshots are taken in a very efficient manner. Okay, so these are details about how it is implemented, and unless you are working on Git itself, there is no need to know that at this point. But the benefit of having this approach is that all the operations are local. Okay, because you have the entire version history with you. If you are working in a particular client here, let's say you are here, you have the entire version here with you. You just don't have the latest copy, you also have all the previous versions, and you can go back to any version you want. So that is why, and so even if your server is not accessible, you can access any part of the source code, provided you commit it. Okay, that is the most important thing to realize. Git is not a magic. Okay, Git is foolproof if you commit. If you do not commit, there is no guarantee that you will be able to get it back. So always get into the habit of, if you start using Git, get into the habit of periodically committing. Okay, yeah, only all this magic will happen only if you have committed your files, and each time you can make commit as much as you want. Okay, you can commit as much as you want. You will not use you will use a very little space, but the moment you are planning to do some change, always make a version which is committing. And of course, if you want to make like a release, like a version 1 release, then there are various other ways of, like tagging or something, by which you can say that this particular commit I'm going to call version 1. Then you start to work on version 2. You might have 100 commits before you go to version 2, before you're satisfied that, okay, now I'm going to version 2. But keep all those commits with you, so that you can, at any point during the development of version 2, any point you want to come back, you can go back to any of the commits which you had. So unless you commit, you will not be able to get back the data. So don't hesitate in committing. Commit as much as you want. So the general 3 stages in Git are, there is a files could be modified, files could be staged, or files could be committed. Okay, so essentially there is you have your working directory. Before you do anything, you can, if you're cloning it from a remote directory, you can, from a remote repository, you can check it out. So either this is usually done with git clone, or if you are creating your own local one, you can do git init, and so you check it out. Then that you have your working directory. You start editing your files, and then if you are thinking, if you feel that your files are reasonably, whatever edits you have made is reasonably good, you can stage them. Okay, staging does not commit, but it is getting ready for committing. So if there are 3-4 files for you to work, you work on file number 1, 2, 3. You finish working on file number 1 and 2, and you can stage it. If you feel that there are no more changes required in 1 and 2, you can stage it. Then you can start working on 3. And when 3 is also done, you can stage 3, and then you can commit. Then all the 3 files will be saved. So staging is a intermediate step which kind of makes you ready to go for the commit. Okay, but that's actually an optional field. That's not necessary, but in some ways it is good. So always to revert back. Sometimes staging will help. So you modify files in your working tree. This is a basic workflow. Select files which you want to be stay part of your next commit. These are added to the staging area. Commit. Next step is commit, which takes the files in the staging area and stores that as a snapshot. So whatever you put in the staging area gets stored as a snapshot when you commit. So files can be either be in one of these 3 states. Okay, committed means the file is not changed. File is there in the repository. The moment you start editing the file, it gets modified. There are some configurations you might need to do if you install Git on your local system. Of course, you can also use GitHub, but it is good to have a local Git client which you can connect to GitHub. You might need to configure your name and your email, and you can configure your editor. Like for example, if you want to give your commit messages, you can give editor. Okay, there is a lot of help available. A lot of online material is also available on Git. Git itself has help. So Git help add, for example, it will tell you various options on how to add. There are, of course, man pages are also there, and there are other ways to get help. Okay, it comes with a lot of documentation. So this is like a sample run. So I'm of course working on the terminal. We are covering only the terminal-based commands for Git. There are also GUIs available. If you are more comfortable with that, you can do it. But terminal gives you more flexibility. Yeah, but there are a lot of IDEs which come directly with inbuilt tools which integrate with Git. That is also there. So now I'm starting a repository by git init, and then I add star.c. So here I'm adding all the C files to the staging area. Add will add it to the staging area. Then after that, I also added like a license file. So all these things are now staged. All the C files and the license file, which is a text file, is staged. And then I commit with some message, initial project version. Okay. So this will now give you a initial repository with some initial versions that have been committed. You can also clone something from GitHub or some other repository which you have access to. So you can either use GitHub, or if you know the IP address and the location of where it is, provided the user has given you permission to access them, you will be able to do it by replacing github.com with the corresponding IP address and the path. So like I said, this is the general workflow. Files could be untracked. That means version control is not being performed. If you want to do version control, you add the file. Git add will add the file, and then the file becomes staged. Then suppose there are already files which are being tracked under version control, then you can start editing them. Then from unmodified, the file becomes modified. If you're happy with your edits, then you can stage. If you don't want the file, you can remove it, and it becomes untracked. And then once you have everything staged, you can commit, and then everything becomes unmodified. And all new changes you do, again, the cycle will repeat. Okay, so unmodified, modified, and staged. There are some basic commands which you will always use. Git status, which will tell you the status of the project. So here, this basically means, here in this case, it means nothing to commit, working directory clean. That means everything is committed. There are no files in the staging area. There are no untracked files. Now then I've changed something in the README file. So now if I do git status, it says that now README has changed. Okay. I mean, I know I have created a new file called README, and it says that this file is now untracked. It's not tracked. Then I add it, so that now I'll tell I want to use version control. So when I add it, automatically adds it to the staging area. And if you do status again, it will tell you that it is ready to be committed. Okay. Because we just staged this file. I'll show you a demo, that is fine. There is also a git ignore file, because you might want in a particular directory, there may be some files which you don't want version control, maybe configuration files or files which keep changing, like for example binary files. Then you can have a git ignore file which will keep track of what you don't want to be tracked. So this will git will ignore these files. Git diff will show you the differences. Also, if you begin a commit, if you do a commit, and if you forget to add a particular file in the commit, then you can git add. Then if you do git commit amend, then it will replace the previous commit with this commit, so that this file also gets included in the commit. Anyway, you will do this when you will get to do this when you do something using Git. Okay. The the great flexibility of Git comes because of branching. So you have a main code which is like your live code or your production code, which you should at any point you should never crash. That code has to run all the time. So if you want to add new features, you would never do it on the production code, because that code is live, which is used by your clients. So you take you make a branch, and by taking a branch and making your commits on the branch, you can do whatever you want without affecting your production code. Okay, branches are only pointers to snapshots and hence are fast. So implementation detail again here. So this is a snapshot of how Git stores things. So there is a particular commit here, and these are some binary objects. So there will be a commit tree. It's basically a tree structure, right? And some metadata is also stored here. And this particular commit has 3 files in it. So this is how a commit is stored. It stores the binary objects which represents the snapshot. So there is a commit tree, and these are pointers to the actual binary objects. Now, okay, my computer has crashed. Okay, so I will. Okay, we are back. Sorry, I thought the computer crashed, but it is still okay. So yeah, so what did we do? So this is my initial commit. Then this is my, just remember the number 98 CA9. Okay. So this was the first one. Then you made some more changes that you call second commit snapshot B, and third commit snapshot C. Okay. Now this is essentially F30AB. Now this is, let's say, here. So the default branch is called the master branch. So initial repository, when you create, everything goes into the master branch. So, and there is a head pointer which keeps to the latest commit. So if head is pointing to, so if you commit a particular version, your head is pointing to that version, right? And I mean, like, so currently now head is so in the diagram, head is a pointer which points to the current branch also. So here we are, because we'll have to check out a particular branch. So currently we are still in the master branch, since we don't have any other branches, and head gives you a link to the most recent commit. And there's also a provision to tag particular commits, so that you can have a simple label for a particular commit, like I said, version 1. Now I create a new branch, testing branch. Okay. So our head is still pointing to the master, but we have a new branch which is a pointer to this particular commit. Now I check out testing. So now my head moves to testing. So this becomes my new head, because we are currently in the testing branch. Now suppose I make a change while I'm in the testing branch and I commit it. So now this becomes a new commit. So now, but we are still in the testing branch. So this is my new commit. Now if I check out master, I go back to the master. I go back to the previous commit, which is originally there in master. So this is new code, which is testing code, but this is my master branch, my production branch. So like this you can, and if you can continue to work on master, you can make a new commit to master. So now master has one new commit, whereas your testing is still in the previous commit. If you want to make new changes, you switch to testing and then make commits here, right? So the tree grows, the version history tree keeps growing. And of course, once you have these two, at some point your production code you want to move back to the master. I mean, your testing code you will want to move back to the production code. For that, you need to merge. So to integrate changes from one branch to another. Okay, this could be between different branches, or it could be between one branch to master, based on what is it that you're trying to resolve. But now merging, because if there is a change in this branch, in this testing branch, and there is a change in master branch, when you merge them, Git automatically fixes merges which have no issues. Okay, so if different lines have been changed, it will directly merge. There is no problem. But sometimes when two people work on the same file, they might change the same line. In that case, you might have a merge conflict, which you will need to manually fix. So this is an example of a merge conflict. So this is from two different branches. So Git will also edit the source code and give you these two labels, which will tell you where the conflict has occurred. Okay. So this is generally about, currently we have seen only about how to, where you are the only developer. There's only one person developing the code. Okay. Now when people have to collaborate, we never talked about multiple people collaborating in the same repository. For that, we need to use repositories which are bare repositories. So in general, Git repositories are of two types, which is a repository which is a working repository which is for working, repository for working, which is called as a working repository, which is usually created by using Git init. So this will contain all your source code and all the other files. So what we saw earlier was all working repositories, what we saw previously. But now if you want to share, then you use what is known as a repository which is bare. So those repositories are created by using the special flag git init bare. Okay, you have to say that it is a bare repository. What is the difference? So in working repositories, you can edit, create, and delete files. It contains your .git directory. So if you go to if you initialize a Git repository, there is a .git folder which is created, and it also contains a working tree with all your source files. And this is also when you use git clone, it includes the .git directory and a copy of the working tree. That is what is cloned to your machine when you are cloning it from GitHub or from somewhere. But in a bare repository, it is meant for sharing. So bare repository does not contain a working tree. Like the name says, it is a bare one. It is bare. It does not have anything. It is only there in the server. So there is a server where the bare repository is kept, and it is usually named with a .git extension. So it's a centralized place to share all changes done by the developers. So it could be in github.com, or it could be, if you're doing it along with your friends, you could designate one computer as your main bare Git repository server. But again, there is no single point of failure as in centralized version control systems. So directly nobody works on the server because the server is bare. It does not have anything with you. So you clone the bare repository, make changes locally. So okay, push changes back to your central repository. So basically, when you clone the bare repository, you're getting an empty repository. You and the other developers add your own files and then push back changes into the central repository. That is done using git push. Now when you push, everybody pushes, everything, the server keep tracks. Okay, now the push has happened, and then you can pull. when all the people pull, everybody's code becomes all people gets all people's code. Okay, and then if there are any conflicts, that has to be resolved. So somebody has to coordinate. So maybe like a project leader or somebody, or or architect or somebody will be doing the most of the coordination. So so in principle, the uh, developers have to make some protocol by which how they communicate with each other, and they will agree, okay, you work on this, I work on this. So they communication is necessary for it to work seamlessly, and there is no problem. I mean, like, this is how large scale software is developed. So there is usually a protocol. So the project leader or somebody will say, okay, I will do this, you do this, you do that. He will assign the work, developers develop, and there is one person who will once the protocol is laid out, all programmers will work as per the protocol, and they'll be able to share the files easily. So suppose there are three programmers. Suppose A is the project leader. Okay, so A creates three programmers, A, B, and C. A creates a bare repository somewhere, maybe in his local machine or in on GitHub. He creates it like this. This is it's like a project for some metrics related work. So it made metrics project.git. A, B, C clone this into some directory on the local machine. So git clean SSH username. This is done using SSH for this moment. We are assuming that the repository is stored in a machine which has SSH access. Everybody starts coding. Then everybody pushes the code. Each person will have a local version of whatever their code they are writing. Then everybody pushes the code. Then everybody pulls the code. Then when you do your first pull, everybody will get everybody's code, provided all the others have pushed before. And then you can resolve conflicts, and then you keep repeating these steps 1, 2, 3, 4. Okay, so this is in general what you will be doing in your project, and also this is typically what is being done. So yeah, this is a remote repository, can be on the. Now, if you were in the lab, you could have done this. This is probably not relevant right now because you guys are at home. One thing, if you have a global IP somewhere, if you have a machine which is a global IP, and if you want your collaborators to access that particular machine, if you're not using GitHub and if you want your own repository, you will have to give the appropriate permissions. Okay, you have to give read write permission to the collaborator in your bare repository. You can make them add them to your group, or you can make it read write to everybody, which is not good if it is a public repository. If you have a public IP address, it's probably not a good idea. Where in GitHub, how you do it is you can add collaborators. Okay, so that is the end of this presentation, and I will. This is just giving you a quick overview, and I will try to give you a demonstration of a simple project which I want you to replicate in as part of this lab. Okay. So I'm going to stop the recording.